beautiful people, and welcome. In this video, we are going to be talking about simplifying radical expressions. When you see the word radical or hear the word radical, I want you to think about square roots, cube roots, fifth roots. So it's something that's going to be having a root. An expression is something without an equals. So you're not actually solving for anything. There's no variable that you need to evaluate what its value is. You're just simplifying the expression. All right, let's go ahead and get started. Disclaimer time. I am human. If I make a mistake, that's okay. I would like to learn from my mistakes, so please let me know if and when they occur. All right, let's start with radicals. So this symbol right here, we're used to knowing that as a square root. Now, the reason we say square root is because there's a hidden 2 here. However, that root or that index can be anything you want it to be. So this symbol is called the square root. And again, we can do square root, cube root, fourth root, fifth root, whatever we want it to be. But in this case, there is a hidden 2 here, and it's defined as you take the square root of a number that's equal to C if and only C squared is equal to A. Now, I want to point something out for you, that every positive number has 2 square roots, a positive and negative. But here's the thing though, the symbol implies the positive root, or it's called the principal. So whenever you take the square root, and we're using square root, whenever you take the square root of something, you're implying a positive root. Okay, you're implying a positive answer. Now, anytime you take the square root of something, however, we're usually saying it's a plus or a minus. So I want to show you the two different examples. If you are solving something like this, and you're trying to get for the value of x, you're going to take the square root of both sides. What you're doing here is you're saying, hey, what does x have to be? So it's basically saying x squared is equal to this 16. And I'm kind of working backwards because that's what we started with. And that's okay because it's saying, what can I plug in for x to get 16? Well, I can plug in for x a positive 4 because a positive 4 squared is 16. And I can plug in a negative 4, which is also negative 4 times negative 4, 16. So when we take the square root and solving an equation like this, you're going to want a plus or a minus. And that's when you're solving for a variable. Now, if you are evaluating the expression, if you are simply saying, what is the square root of 16? That's simply a positive 4 because we're not solving for anything. We're just simplifying. It's, for example, saying you're going to simplify 5 squared. Well, 5 squared is 5 times 5, which is 25. There's no negative here. There's no negative that's telling you that this 25 is going to be negative because this term, this expression doesn't have a negative in it. So because this doesn't have a negative in it, this is going to be a positive 4. Now, if you had evaluate this type of expression, then it would be a negative 4 because the square root of 16 is a positive, and we have a negative on the outside, therefore it would be a negative 4. Big difference in solving for a variable. Please keep that in mind. All right, so let's go ahead and jump into some properties that we're going to need. Some rules. The first rule we're going to need is called the product rule. And I personally think the product rule is pretty cool. And what that means is if you take the square root, and it can be, let's do square root of A times B. And we're going to separate them out. So if you have A times B inside of a radical, right? You can't split that up because multiplication is king. If you're in my classroom, you already know that multiplication is king. So because we have multiplication only works with multiplication, we can undo that and say the root of A times the root of B. Those are exactly the same thing. Now we can go backwards and forwards. So if we have this, we can combine them as well to do one root of A times B. Now the catch is it has to be the same root. So for example, these are both square roots. There's like a hidden 2 here. So these have the same index or these have the same roots. Let's do an example of a product rule. Usually we use this method when we are simplifying, and that's what we're doing. But I just caught what I was going to say. But usually we do this when we're simplifying expressions, and that's what we're doing. We're simplifying expressions. All right, so let's do the square root of 80. So the square root of 80, we can split this up, and we want a pretty number in one of them. Oh, let's actually back up a little bit. I'm going to undo that multiplication. So I'm going to factor 80 into 2 factors. You can do more if you'd like. It doesn't have to be 2. It could be more. So what I can do, 80, 8 times 10. But 8 times 10 doesn't help me because I can't take the square root of 8 and I can't take the square root of 10. Oh, 16 times 5. So that means I can do the square root of 16 times the square root of 5. And that means I can do square root of 16 is positive, or again, when we're just simplifying, it's always positive. And we have 5 left over. Let's do another example. Square root of 125. That is the square root of 25 times 5. Ooh, another 5. That means I have the square root of 25 times the square root of 5, which means I have 5 root 5 as my simplification. So the second one is called the quotient rule, second property that we're going to use, or second rule. Now the quotient rule states, oh, you guys can't see that. The quotient rule states that we have a square root of A divided by the square root of B is exactly the same as taking the square root of the fraction of A over B. Now, just like for the product rule, we can go the other way around. So if we have the square root of the fraction A over B, we can rewrite that as the square root of A divided by the square root of B. And again, the index has to be the same. For example, if this is square root of 2, then this is the square root of 2. If this is a square root, then this has to be a square root, and this has to be a square root. Same thing for the top. All right, let's go ahead and do an example. Let's switch colors. So we have the square root of 24x to the 11th power divided by 3x to the 7th power. Notice that I have a square root on top and a square root on the bottom. I can rewrite these as a fraction, so 24x to the 11th power divided by 3x to the 7th power. This here inside, I'm going to combine 24 divided by 3 times x to the 11th power divided by x to the 7th power. I know that 24 divided by 3 is 8. I also know that these right here, if I have x to the 11th power divided by x to the 7th power, that means I have x to the 11 minus 7 power because we're using the property of exponents. That means I have the square root of 8 times x to the 4th, which means I have, again, I'm going to split this up. The task here when simplifying is to keep splitting things up until you can't split them up anymore. Here I can do 4 times 2. Oh, and I'm going to extend this because I still have my x. Oh, you know what? I'm thinking in my head, x to the 4th can be rewritten as x squared times an x squared. But this can actually, you know what? I'm taking that back. Because we want to undo squares, I'm going to rewrite it as x squared squared. Because 2 times 2 is 4, and that's what we have, and therefore I can undo this. So this is how it's going to look like. I have the square root of 4 times the square root of 2 times the square root of x squared squared. So that means, again, this is now the product rule. So we started with the quotient rule, but now we're going back to the product rule. So that means the square root of 4 is 2. The square root of 2 is still the square root of 2. The square root of x squared squared, these cancel out. So I have x squared. I'm just going to write it in front, not behind, so it's not confusing what is actually being square rooted. And that is it. That is our final simplification. Let's do another one. That one's a little bit complicated. So let's do the square root of 48y to the 9th power divided by square root of 3y cubed. Again, we're going to rewrite that under one root as a fraction on the inside. We're going to start splitting things up. Numbers go together. Again, we can do this because of multiplication. Multiplication is king. We love multiplication. 48 divided by 3 is 16. So I have the square root of 16 times, I'm going to subtract these. So 9 minus 3 is 6. So now I'm going to use the product rule. So the square root of 16 times the square root of y to the 6th power. Now I am going to split up y to the 6th power. Oh, you guys can't see that. I apologize. I'm going to split up y to the 6th power more because I want to simplify it further. And I can split up y to the 6th power as y cubed squared. And again, I'm using those exponential properties because 3 times 2 is 6, and that's what I have as my exponent. So now I get to say the square root of 16 is 4. The square root of y cubed squared. So the square root and the square, they cancel each other out. So I'm just left with y cubed. There's nothing else for me to simplify, so this is my final answer. So you also want to, we kind of brushed a little bit on it. I mentioned it one time or twice now that we're using exponential properties. So make sure that you have those out. If you need to watch one of my previous videos, I did list those out. Or an easier way is just to go to Google and type in the exponential properties. Type in PDF at the end of that statement. So exponential properties PDF, and you're going to end up getting a lot of PDFs. If you have a printer, just print them out. If you don't have a printer, you can still copy all of those down that way. All right, let's go ahead and see about adding and subtracting. So when we're adding and subtracting radical expressions, let me switch my page. Here's the thing, they must be like terms. Think of it this way. If a root is a bubble, then you're counting or subtracting bubbles. So the radicate must be the same. And the radicands, that is what is the inside. And the root also has to be the same. And the root index is this guy right here. Okay, my hint, like I mentioned before, is treat each root as a bubble. Identical bubbles can be added and subtracted. So if you have something that's being added but the bubbles don't match, you can use the property, the quotient property or the product property to simplify an expression first and then combine like terms. So if you have bubbles that don't match, try to simplify the bubbles. Then combine. Okay, let's do an example. Let's put this to use. We have 4 square root of 72 plus 7 square root of 8. So we're going to put them in bubbles. And I'm going to put in bubbles the square roots only. So like the 4, I'm going to omit the 4. So we're trying to see if these have to match. They don't. So that means we have to try and simplify. This just means I have 4 times this bubble and I have 7 times this bubble. So I have 4 times the square root of 72 and I have 7 times the square root of 8. So square root of 72, let's see if I can rewrite that. So I'm going to have 4 times the square root. We're using that product property. I have 36 times 2, and I have 7 times the square root of 4 times 2, which is 8. I'm going to continue using that product property, which is the square root of 36 times the square root of 2, and 7 times the square root of 4 times the square root of 2, and 4 times the square root of 36 is 6 times the square root of 2. And I have 7 times the square root of 4, which is 2 times square root of 2. Now that we have things the same, we start to combine, but here's the thing. Make sure you're doing things like in order, like multiplication comes first. Yes, I get that all of this is multiplication, but we're going to leave these out for our next step. So 4 times 6 is 24. So I have 24 root 2's here, and I have 14 root 2's here. So this is 24 root 2 bubbles, and I have 14 root 2 bubbles. So how many total root 2 bubbles do I have? Well, I'm going to add those quantities of bubbles. So I have 24 and 14. That means I have 38 root 2 bubbles total. And that is your answer. So you can combine as long as you can make sure that these bubbles are the same. So these bubbles initially were not the same. However, we were able to use the product property to simplify them, combine things here, get them to the same bubble, and therefore we have 24 bubbles and 14 bubbles. So how many bubbles total do we have? 38. Alrighty, let's go ahead and see if we can combine all of them. Oh, let's do this one here. This is important. So this is multiplying radical expressions. But we already did multiplying. This is going to be different. With more than one term. So you're going to have something like, and we're just going to do an example. I don't really have like a property for this. It's just, I'm going to show you what to do. So for example, we have 2 square root of 3 minus 5 square root of 2. And that's being multiplied by 3 square root of 3 plus the square root of 2. So when you have something like this, multiplication is king. However, now we have a minus here and a plus here inside the bubble, separating these two terms. So with that being said, you can either use the box method or you can use the FOIL method. With whichever you prefer. I prefer the box method for anything like super complicated. It just helps me organize my thoughts. You don't have to. But anything that is attached to an addition or subtraction, we kind of don't like that. After a certain point, addition and subtraction kind of complicates things for us. In grade school, we love it, but now it's a little complicated. So when you're doing this, you're going to multiply this stuff. So for example, 2 times root 3, this is what this is. Then we have times 3 times root 3. So 2 times 3, that's 6. 3 times root 3, that means I have root 3 squared, which means after I simplify everything, I have 6, I'm even running out of space, 6 times, what is it, 6 times 3. So this bubble, I'm even going to write it on the top in a circle, is actually 18. Let's do another one. I'm kind of regretting how small I made these bubbles, but that's okay. -5 times root 2 times 3 times root 3. So that means I have -5 times 3, that's -15. So these go away. Then I have a root 2 times a root 3. Make sure you know your product property, which means I have a -15 times a root 6. Now let's do this one here. I was thinking if I can simplify 6, but I can't. 2 times root 3 times root 2. So I have 2 times root, what is this, 6? Then what do we have, the last one? Last one we have is a negative 5 times root 2 times root 2. So then I have a negative 5 times root 2 squared, which means I have a negative 5 times 2, which means I have a negative 10. Now we're going to combine like terms just like we did before when we were multiplying polynomials. So what do I have here? I have, what is this? 18. 18. Then I have combining here. Again, bubbles are the same, so we can add and subtract these because I have negative 15 bubble, which is root 6, and I have positive 2 bubble, which is root 6. That means I have a negative 13 root 6 bubbles. Then I have a minus 10, which then I'm going to simplify even further, which gives me positive 8 minus 13 root 6 as my simplified. All right, beautiful people. I'm going to go ahead and wrap up this video right now. There will be a part 2 where I'm just going to go through more and more examples, more complicated examples. But here I just wanted to introduce all the different types of things that you're going to be seeing when you're simplifying your expressions. Thank you so much for watching, and I will see you in part 2.